All right. Hello, Emily. So I'm just going to go through these notes as if you were actually in class. So this next and last lesson is divided into 2 days. So the first lesson you would have received on Tuesday, and then to finish up this lesson, it's going to be on Wednesday. Thursday, we're reviewing for the test, and then Friday is the actual test. So these are the notes from day one, which will be on Tuesday, September 5th. This last topic is something called literal equations, and more on that in just a second. But we're going to be starting class with just a little warm up. So I want you to go ahead and try this warm up. And so go ahead and pause the video because I'm going to go right into solving this. So the warm up says if that you have this equation x plus 2 over 3 all equal to m, and then you're given that m has a value of 5 and you need to solve for x. So this is a type of problem that we should already be able to do given lessons from last week on proportions. So we're given some really important information here, the fact that m is equal to 5. So wherever we see an m in this equation, specifically right here, we're going to get rid of it and write 5 instead because we know that m is 5. So I'm going to go ahead and rewrite this equation. So x plus 2 all over 3 is equal to 5. I'm not going to write 5 though. I'm going to write it as a fraction. So 5 can be written as a fraction as just 5 over 1. Again, I didn't change that number. 5 over 1 is still just the same thing as 5. From here now, I just need to cross multiply in order to solve for x because I have two ratios equal or proportional to each other. So to solve, I cross multiply. The first cross multiplied items are x plus 2 and 1, but anything times 1 is just whatever that number, variable, or whatever it is. In this case, it's just x plus 2. So x plus 2 times 1 is just x plus 2. And that's going to be equal to the cross multiplication of my other two items, and my other cross products are 3 times 5. So all equal to 3 times 5. I'm going to simplify this because I know what 3 times 5 is. So on the left-hand side, I still have my x plus 2, all equal to 3 times 5 simplifies to be 15. From here, it's just a one-step equation. I have to get x by itself, so I have to get rid of this positive 2 term right next to it. So I do the inverse operation of that. I subtract away 2. What I do to one side of my equation, I have to do to the other. So I subtract 2 on the right-hand side as well. When I simplify, on the left-hand side, a positive 2 minus 2 cancels each other out. It's just 0. So they go away. That was the whole point of doing that because all that's left on that side now is just x, which is exactly what I want. And that's all equal to, okay, on the right-hand side, I actually have 15, but I'm taking away 2, which is now simplifies to be 13. And I receive my answer. What is the value of x? Oh, here, I just solved for it. X is equal to 13. So from there, we would actually go into the lesson for the day, which is on this last topic called literal equations. So what is literal equations? It's basically just the process of solving an equation for one specific variable. So it's the process of solving an equation for one specific variable. So far, what we've been doing in class is we have been given like an equation, like a one-step, two-step, or multi-step equation, and there's only been one variable. And in algebra, if there's an equation with just one variable, we can kind of manipulate the equation to solve for the exact value of that variable. Kind of what we did up above. Yeah, technically this actually had two variables, x and m, but we were able to get rid of that second variable m and replace it with 5 because that's what I was told m was. So if you only have one variable in an equation, then you can kind of manipulate that equation just like we did here in order to solve for that exact variable x. But with literal equations, there's going to be more than one variable. There's going to be 1, 2, 3, 4, maybe 5 variables. I don't know. It depends on the question. There's going to be more than one variable, and you're going to have to manipulate the equation in order to solve for a specific variable. And in doing so, you will never know the exact value of the variable that you're trying to solve for because there's more than one variable. You're basically going to get an equation at the end. So this is going to be kind of different, and it's also going to be a little complicated. I think this topic is the toughest and it's going to be the hardest. So when you return, I would highly encourage you to come to ASP, my ASP second period, because you're going to need help on this. It's a tough topic. So don't be ashamed if you don't get it. It's tough. Many people are going to have issues. But the notes down below. Everything on the left-hand side, we should be able to do. All these are our one-step or two-step equations. On the right-hand side is similar problems, but instead of having just one variable, we now have multiple variables. The problems you will see are very similar, and the processes that we'll be taking are also very similar, but you'll see that with literal equations, it is just a little different. You're kind of manipulating the equation with nothing but variables. So it's just a little different. So let's talk about the stuff that we do know first, and then after that, we'll talk about how literal equations is just a little different. So looking at this first one, y minus 9 equals 34. This again is just a one-step equation. I'm going to try to emphasize things with colors. So any step that I'm taking, I'll use red. And then all my work, when I simplify things to go to the next step, I'll show it in pencil. So to solve this equation, y minus 9 equals 34. And I'm being asked to solve for y. Well, I'm trying to get y by itself. Again, if I look at this equation, on the left-hand side, I do have my variable y, but I have something along with it. There's this term minus 9. I need to get rid of this term minus 9 in order to truly solve for y and get y by itself. So I need to do the inverse of minus 9. I have to add 9 to both sides. Again, what I do to one side, I have to do to the other. And when I do that, this whole negative 9 plus 9 on the left-hand side, because they're inverse operations, they cancel each other out. Negative 9 and positive 9 combine to be 0, so they go away. And I'm left with just y on that side. I got my equal sign in the middle, but then on the right-hand side, I have 34 plus 9. So when I combine a 34 and 9, let me see. So I got my calculator here, 34 plus 9, those combine to be 43. So on the right-hand side, I have 43. When I look back and reflect, I notice, oh, wow, I'm actually done. I figured out what y is. Y has a value of exactly 43. So this, again, is something that we should be able to do. That was just a one-step equation. Let's take a look at what this looks like when we solve something called a literal equation. So notice on the right-hand side, it looks very similar. We have some variable, c, just like we had the variable y. And then we're subtracting off, a variable d. In our previous problem, it was an actual number 9. But then we have our equal sign, and then to the right of the equal sign, we had 34 on this problem over here, and now we have a variable. Dang, there's lots of variables in this problem. These two problems, however, are almost the exact same problem. The only thing is this whole minus d is now a variable instead of minus 9. Like, we don't know what d is. It could be 9, it could be 10, it could be 50. We still have this equals some number e. Yeah, it's not equal to an exact number 34, but again, this equation is pretty much the exact same format. We have something minus something equals something. Something minus something equals something. Because the format is pretty much the same, we're still going to be following the exact same process. However, we're not going to be moving numbers around. We're going to be moving variables. But again, the rules and process are the same. Nothing really changes. I'm being asked to solve for c, the variable in this spot. Notice that's the exact same thing that I was asked to solve for here, y, the variable in this spot. Well, to do that, in order to get c by itself, so I have my two sides of my equation, the left-hand side and then the right-hand side. If I'm being asked to solve for c, which is this variable right here, c is unfortunately not by itself yet. It has this minus d kind of tagged along with it. So what I need to do is to get c by itself, I have to get rid of this minus d term. Well, how do I do that? It's the exact same process as before. I have to undo a minus d here. Well, what's the inverse of subtracting d? Well, the inverse of that is adding whatever that number is. It just happens to be a variable, d. So I'm going to add d to both sides. If I do it on this side, the left-hand side, I have to do it on the right-hand side as well. So I'm going to add d to this side. Notice, though, when I added d to this side, I did not put it underneath this variable e. The reason I did that is because this e and this d variable, they're different letters, so they're not like terms. We cannot combine them together. So when I simplify, again, a negative d plus d, I'm taking some number, some negative number, and adding it to itself. Well, that's just going to cancel out. It's kind of like taking negative 5 plus 5, or negative 5,000 plus 5,000, or negative 1,000,000 plus 1,000,000. Whatever that number is, if I add it to itself, it's going to cancel itself out. So all I'm left with on the left-hand side is just c. I got my equal sign in the middle. And then on the right-hand side, I have a variable e, and then I'm adding d to it. Again, these are not like terms, so I cannot combine them. I literally write it just like that. Now, what's typical is that things are usually written in alphabetical order. So d comes first in the alphabet. It's positive, so I don't put a sign in front of it. And then this e, there's no symbol in front of it, so it's assumed to be positive. So I'm going to use the addition side to indicate that e is positive. This is my final answer. I've solved for c in terms of my other variables. What I did is I just moved d to the other side. C is all by itself over here. And what this equation is saying is, well, in terms of c, this variable then is equal to whatever d is, and then add it to whatever e is. So this is my final solution. Again, it's kind of the same over here. My y was equal to my 34 plus my 9. So it's kind of like my 34 is my d, my e is my 9. So the only difference between these two types of worlds, before we were able to solve for the very specific value of our variable y, because we only had one variable. We were able to solve and notice that it was 43. However, with literal equations, there's just tons of variables. So what we're doing is we're not solving for exactly what c is. We're just solving for what c is in terms of the other variables. So that's what a literal equation is. It's just manipulating an equation using the rules that we've learned in one-step, two-step, and multi-step equations. So moving on, try to go a little faster now because I kind of broke that first problem down immensely. So I'm hoping that helped. So problem number 2. Again, this is something that we should be able to do. Negative 6x equals negative 30. When we have a number like negative 6 right next to a variable, x, it's assumed to be multiplication. So this negative 6 is multiplying my x. Well, to get x by itself in this case, I have to do the inverse operation of that multiply by a negative 6. Well, the inverse of multiplication is division. So now to get x by itself here, I have to divide both sides by that coefficient in front of x, the negative 6. And when I do that, negative 6 divided by a negative 6 is just 1. So any number divided by itself, like negative 6 divided by negative 6, it's just 1. Well, that's the whole point of doing this, because now my coefficient in front of my x variable is just 1. So I have 1x all equal to, now on this right-hand side, I have a negative 30 divided by a negative 6. So negative 30 divided by a negative 6 is 5. So I get my solution. X is all by itself over here. I've solved for x. My x has a value of 5. Well, let's do something very similar, but let's look at it from the perspective of a literal equation. Here we have, you've probably seen this formula before in middle school, because you guys talk about a little bit about geometry with something called circumference of a circle. So circumference equals 2 times pi times r, which stands for radius. Well, in this particular problem, I want you to take this very famous formula, very popular used formula, but I want you to solve for it in terms of r. So I want this r to be all by itself. The problem is I have a pi right next to it and I have a 2 right next to it. Now this is all one giant term. Remember, terms are just separated by addition signs, subtraction signs, or equal signs. There's just straight up multiplication between this number 2 and pi and the pi and the r. So this is, again, one giant term. So 2 pi r. In order to get rid of this 2 times pi that's multiplying my r, again, I have to do the opposite of multiplication. So to undo this multiplication of 2 times pi that's multiplying my r, I have to do the inverse of that, which is division. So I'm going to divide both sides by the coefficient in front of r, which happens to be 2 times pi. So I'm going to divide this side by 2 pi. On the left-hand side, I have to do the exact same thing then. I'm going to divide this side by 2 pi. So let's take a look at what that does. On the left-hand side, I have my variable c, circumference, all divided by 2 times pi. Nothing I can really do to simplify that. So circumference divided by 2 pi. I got my equal sign in the middle, and then on the right-hand side, I have 2 pi times an r, all divided by 2 pi. Again, this 2 on the top and 2 in the bottom, 2 divided by 2, is just 1. It's going to cancel each other out. Same thing with this pi. Pi on the top, pi on the bottom. Pi divided by pi, any number divided by itself is just 1. So they cancel each other out. And the only thing that's left on top is r. On the bottom, there is something left. It's really just a 1 since all these things canceled out to just be 1. So simply, I just have r on the right-hand side. And this is my solution now. I've manipulated this equation to get r by itself. R is always going to be equal to, in any circle, your radius is equal to the circumference divided by 2 times pi. Finally, number 3 here. It says solve for y. So I have y divided by 4, all equal to 8. Again, I need to get y by itself. What's with y that I need to get rid of? Well, it's this whole divided by 4 business. So I need to somehow undo this division by 4 to get y by itself. So I do the inverse of that. Well, what's the inverse of division? It's multiplication. So I'm going to multiply by 4. Because I have fractions on this side, I'm actually multiplying by 4 over 1. Same thing as multiplying by 4. So on the left-hand side, I multiply by 4. Well, on the right-hand side, I have to multiply by 4 to balance out my equation. The beautiful thing about this is when I do that on the left-hand side, I have a 4 on top and a 4 on the bottom. I essentially have 4 divided by 4, and that cancels out. 4 divided by 4 is just 1. So I'm left on this side with y all over 1, which is just simply y. I got my equal sign in the middle, and 8 times 4 on this side simplifies to be 32. 8 times 4 is 32. And I get my solution. Y is equal to 32. So let's take a look at how a similar problem, but in terms of like literal equations. So nothing but variables in this problem. And I'm being asked to get m all by itself, this variable m. So this m on top, I somehow need to get rid of this v on the bottom. Well, there's actually 2 ways that we could look at this problem. What I'm going to encourage people to do in class is like whenever you're given a fraction, because everybody's doing pretty well with ratios and proportions. So if you're given like a fraction on the right-hand side, turn the left-hand side into a fraction as well. So put that d over 1. And now we have 2 fractions, aka ratios. We have a fraction or a ratio on the left-hand side, and a fraction or a ratio on the right-hand side. And they're equal or proportional to one another. Okay, well, kind of similar to like this warm-up problem that we were looking at. If you have 2 fractions on either side of the equal sign or 2 ratios, like nothing but fractions, then you can use cross multiplication to solve. So let's use cross multiplication here. The first set that I have is 1 times m. And anything times 1 is just, it's whatever that other number is. In that case, it's a variable. So 1 times m is just 1m. And that's equal to the cross product of my other 2 items. So my other cross products are d in v. So I have some variable d multiplying some variable v. Again, it's kind of awkward to write this multiplication symbol, so we can kind of just get rid of it. So m equals d times v can just be written like this, no little dot or multiplication symbol in between. And that's what I was asked to do, solve for m. Hey, look, m is all by itself on the left-hand side of my equation. So what this is saying is the variable m is equal to all my other stuff is on the other side of my equation. I've accomplished what I need to accomplish. I've written this equation in terms of m. Let's look on the back-hand side. Got word problems. But don't be freaked out too much about this. There's a lot of words always in these like literal equation word problems, but there's very little that you have to really truly understand with all these words. Basically what you're looking at in literal equation word problems is what formula are you given. So let me try to use colors here. We're given this equation. A equals BH. And then the other thing that you really have to know is, okay, what variable do they want you to be solving for? What variable do they want alone? And that's usually in the last sentence. And here it says in the last sentence, determine the base dimension of her garden in terms of A and H. So we're looking for, okay, let's get this equation in terms of the base. Determine the base. So those are the two important things. Again, I didn't even read this problem because everything else doesn't really matter. Let's go ahead and just read it, and then I'll kind of explain why it doesn't really matter, all those other words. But Ms. Jacobs is planting a rectangular vegetable garden. She uses the area formula, area equals base times height, to calculate the area A based on the base B and height H of her garden. Determine the base dimension of her garden in terms of A and H. I think all those words are very confusing. This is basically what the problem is asking for. Hey, it wants you to solve for this variable base, which is represented by B. So what variable are you trying to solve for? The letter B, which again means base in the formula. Okay, what equation are we using? They always give you the equation. They have to. Area equals base times height. A equals B times H. Okay, so we're going to take this equation. We're going to manipulate it a little bit in order to get the variable B alone by itself. So that's what this problem is asking. You don't have to worry too much about the vegetable garden, what all these words mean. So let's look at this equation. A equals B times H. Again, we're trying to get this variable by itself, B. So what's with B that we need to get rid of? Well, this other variable H is on this side. So we need to somehow get rid of this H. So again, we have to ask ourselves, okay, what are the B and the H doing to each other? Well, it's kind of invisible, but there's an invisible multiplication in between those two letters. Again, if two letters are just side by side with no symbol in between, no addition, subtraction, multiplication, or division symbol, it's assumed to be multiplication. Okay, well, now that B and H we know are multiplying each other, how do we undo that multiply by H? Well, we'd use inverse operations. We're going to have to divide both sides by whatever is multiplying that B. In this case, it's the letter H. So if I'm going to divide the right-hand side by the letter H, the variable H, I have to do the exact same thing on the left-hand side. So let's take a look at what that does. On the left-hand side, I'm left with just A, the area, all divided by H, the height. So A over H. Got my equal sign in the middle. And then on the right-hand side, I have an H on top and an H on the bottom. Essentially, H divided by H, any number divided by itself just cancels itself out, and it's just 1. So those are essentially gone. And look at what I'm left with, B. That was my actual goal here, was to get B by itself. So this is perfect. This is now my solution. So that letter or variable B, I'm just going to kind of switch sides here. My variable B is equal to, again, my variable A all divided by H. So this is my solution. I have rewritten that equation in terms of B, my base. Now let's take a look at this last word problem. So we're given this formula. Not worried too much about the words in this word problem, but I'll read it in just a second. We're given this formula t equals d over r. Who knows what this means? Let's not worry about it for now. And then we need to, the last sentence it says, find the rate r. So we are rewriting this equation and trying to get r all by itself. So we're trying to get rid of this d and put it on the other side, essentially. So again, looking down below, and I'll read the question in just a second. What variable are you trying to solve for? Again, that's always located towards the beginning of the last sentence. Find the rate r. So we're trying to manipulate this equation so that r is equal to, and then everything else on the other side. So we're trying to find r, which is the rate. Okay, using what formula? What equation are you using? Hey, they gave us this equation. So t equals d over r. So let's go back and kind of read the question so we kind of know what's going on here. But technically, now that we know this, we don't really need to know the context of the question. The context is kind of unimportant. But just for the sake of kind of expanding our knowledge, Mary wants to beat John in a race. She used the formula t equals d over r to figure out how fast she needs to run in order to pass him. Find the rate, which is r, at which she needs to run. So what speed does she need to run to win the race in terms of the distance, which is d, and time, which is t, for which she runs? Okay, so let's take this equation. T equals, what is it, d over r? And again, we're trying to get r by itself. There is more than one way to solve this problem, but what I think everyone will truly understand a little better is this method. Again, we have nothing but a fraction or a ratio on the right-hand side, right? So if we do have nothing but a fraction or a ratio on the right-hand side, then make the other side of your equation, so this t, make that a fraction as well. So in order to make anything a fraction, we just divide it by 1. I have transformed this equation such that both sides are nothing but fractions. And the reason why this is wonderful is because everyone's doing really good with ratios and proportions. So now that I have a ratio, t over 1 on the left-hand side of my equation, and then a ratio of d over r on the right-hand side of my equation, with an equal sign in the middle, so these ratios are essentially proportional, I can use cross multiplication in order to solve. So the first set of cross products that I get is, let's just look at this one first, t times r. So t times r. Again, if I'm representing two variables multiplying each other, I don't have to write that multiplication in the middle. And that's equal to the cross product of my other two items. I try to use a different color. So my cross product of my other two items is 1 times d. Again, any number times 1 is just itself. So that's just 1 times d is just d. The question is, am I done at this point? Well, if I look back at what my goal is to solve for which variable? Oh, that's right, r. Well, r, unfortunately, is not by itself right now, so I have a little work to do. R, again, is not by itself on the left-hand side. It has the variable t right next to it. The question becomes now is, how do we get rid of that t? Well, to answer that question, you have to ask what that variable t is doing to your r. Remember, t was multiplying this variable r. So how do we undo that multiplication? We do the inverse operation of multiplication, which is division. We have to divide both sides by the coefficient or the number, in this case variable, in front of my r, and that's t. So if I divide on the left-hand side by the variable t, I also have to divide on the right-hand side by that variable t. The reason why this works out so beautifully is because on the left-hand side you have t on top, t on the bottom. Well, t divided by itself is just 1. All of this cancels out. And on the left-hand side I have just r. Equal sign in the middle. And then on the left-hand side, I have the variable d divided by the variable t. There's nothing you can do to simplify that. And this is my final solution. Remember, I'm trying to get r by itself. Well, here, r is finally by itself. And I've rewritten this equation such that everything is in terms of r. R is equal to, and everything else is on the right-hand side. R is equal to d over t.